What if you could immediately have your child think about a piece of art, maybe one from Monet or one that they've drawn themselves or one that you've shown them, where they could immediately think about percentage, fraction, and decimal in terms of the image. Estimating is a really important part of working with fractions, decimals, and percent. So in this activity, which I encourage you to do with your child anytime you see any image or any group of anything, talk about estimating fractions, decimals, and percent. So this image is called Haystacks, I believe. It's from Claude Monet. So what I would do is ask my child or ask a child, what fraction of this picture do you think is the haystack? And what's important here is that the child thinks that this entire picture is all if this picture is one whole or 100%. That's obviously makes sense. That's where they begin. So how would they break it up? Well, you leave it up to them, which is the beauty of it. Some kids will start by like tracing what they're thinking about and then just throw out a random number like 50% or 1/2. But generally speaking, the fractions are not that accurate, which is a great place to start though, because at least they're beginning to think. So in this example, and whenever you think about fractional parts, you really do need to make the fractional parts equivalent sized pieces, and that's an important aspect of this activity. Even if I just go in here and I break this image up into 4 parts to start, then your child can start to think, is 1/4 about correct? Well, if I take this piece and this piece and move it down here, and then if I take this little triangular piece and put it right here, and then this piece, can move it to maybe fill around this much space. So then I can begin to see, and hopefully my student will understand, that this is actually less than 25%. So then I would want the child to take the same picture and maybe try to be more precise. So now I've cleared out the picture, and we're going to start again knowing that this haystack section is less than 25% of the picture. And maybe again, if we have the child, instead of doing fourths, we could even begin with fourths, but then keeping in mind we need to make equal sections, and I'm doing my best. Now I've made eighths. And you know, I'm just going to go smaller and make, now I've made 16ths, 16 equal pieces. And let's look at our haystack again. So this piece is totally full. So this is 1/16. And then let's see if we can take everything else and fill up this section, which is already partly full. So if I move this part, you know, students could even take tracing paper to sort of be more precise. So I move that part over. I take this triangle, put it right here, and then I've got this section down here. And if I move that up here, I would think a kid would say it's about almost all the rest of the space. But then maybe this piece also fits in there, like right in here. So now I've got, so this piece is gone. You gotta be organized. This piece is gone. This piece is used up. This piece is gone. This piece is gone. So I've got this section and this section. Well, this section is almost 1/2 of a 16th. Especially if I take this triangle and move it in here. Now I really think that I've got 1/2 of a 16th here. And so your student will have to think carefully. If this whole thing is 1/16, then half of a 16th is 1/32. I don't actually have pieces of fraction bars that are that small. So it's going to take some discussion to figure out why 2/32 is equal to 1/16. But once they figure that out, they can transfer all that knowledge to their answer. Everything all together is 1, 2, 3, 4, 5/32. Now, ask them to convert that to a decimal and percent, and that gets really hard. So they would estimate. And if they thought that there are 16 pieces, if each piece is around 5%, they would skip count and find out that's only 80 total. So then they could roughly figure out that it's about 6% per piece. because 6 times 16 is 96. So it's 6% for these two, or 3 plus 3 plus 3 plus 3 plus 3. So 3, 6, 9, 12, that's about 15%. 15% is equivalent to 15 out of 100. And as a decimal, it also says 15 hundredths, so I can write 1, 5 like so. But at this point, you could use something like a Desmos calculator and remind students how fractions are little mini division problems. And if you type in 5 divided by 32, you get 0.15625, which looks a lot like the decimal we already have, so that's good. Now, the idea of thinking why 5/32 is very close to 15 hundredths is a really important conversation too. Does it look like about 15% of the image is filled in? Yeah, maybe. Most kids would say it seems low, but that's what we came up with. Then you'd have kids share their answers with each other or as a group to decide which ones seem more accurate, which ones seem less accurate. I hope this helped. Please like and follow for more, and don't forget to subscribe. There'll be a lot more about decimals coming up. Thank you.